I don't know why we are pink right now. Okay. All right, so if I asked you to find the derivative of this function, you don't have to write this down. This is just us talking. Then you see how there's two different y values? You would have to say y minus 4xy equals, and add the 3x over, and then factor out a y. 1 minus 4x equals 3x plus 2. And then solve for y, and then take the derivative using the quotient rule, right? But the problem is, what if that was a y squared? So if this was y squared, and I factored out the y, I would still have a y in it, and I could not solve for y. Literally could not. So you have to have an ability to be able to differentiate even when you can't solve for the variable y, because not everything is explicit. Explicit functions are like y is in terms of x. Y is a function of x. And they're all, you can graph them on y equals, right? But sometimes you're going to have functions that are not. You're going to have functions that do something like that. And that would be graphed by an explicit function, or sorry, an implicit function. Implicit because it's not x in terms of y, it's not y in terms of x, it's both x and y in the function. And you notice how like this is something equals to. It's not a function equals expression. It's actually ends up being an equation. So you've got implicit equations that you're deriving. So, and we'll talk about graphing those later, all right? So 3.5, implicit differentiation, is what you're going to talk about today, or take your notes over. So 3.5. And here's some lovely blue ink. Okay, so again, an implicit function is a union of separate functions. Explicit function for each x, there's unique y, so y equals a function of x, and then when we have implicit uniqueness, it's not a given. Okay? So if I ask you to derive sine of f of x, yeah? So this is chain rule. The derivative of the outer function sine is cosine. Leave the interior function alone, but then multiply by the derivative of the interior function, right? Well, f of x is just another way of saying y. So if I ask you to find the derivative with respect to x of sine of y, which is a function of x, then that's cosine of the interior y, leave it alone, but then times by the derivative of the interior y prime. Okay? So in fact, every time you take the derivative of y with respect to x, you have to tack on a well, I was about to say a dy dx. Some books and some people like to use this notation. Some people like to use this notation. Just be careful about this, that it doesn't become a y to the first power, or it doesn't become a y prime when it's a y with an eraser marking. You just got to be careful. So either one. So if I said find the derivative of this equation, right? So you take the derivative of each of them individually. The derivative of x squared is 2x. And if you wanted to tack on a dx, you would notice that they would simplify out, so you don't need to worry about that. Plus, the derivative of y to the fourth, we'll treat it like an x, so 4y cubed. But then, remember that this is the same thing as saying f of x, so it's an implied chain rule. So I've got times y prime, or dy dx, equals, the derivative of 2x is just 2, and then your goal is to solve for y prime. So y prime equals, I'm going to subtract the 2x and divide by 4y cubed, which we could simplify to 1 minus x over 2y cubed is y prime. Okay? So when I derive, I just have to remember that y is a function of x. So every time I take the derivative, I got to tack on a y prime, or dy dx. All right, so the derivative of x times y with coefficients in front of it pops up all the time. So you just got to remember that this is a product rule. So f g prime plus f prime g. F is x, and g prime is the derivative of y. The derivative of y is 1 times y prime, or the derivative of f is f prime, right? And then plus the derivative of f, which is x, is 1, and then times just g, which is y. So you kind of get used to saying xy prime plus y. Xy prime plus y. So if someone asks me, what's the derivative of 7xy? I'm going to be 7xy prime plus 7y, because I consider 7x to be the first function and y to be the second. Okay? You got to be careful though, because sometimes it's like a negative 3xy. So that would be a negative 3xy prime minus 3y. Just Just multiply xy prime plus y times the coefficient. All right, finding the slope on a circle. Find the slope of this circle when x equals 8. So what is dy dx at x equals 8? Okay, well I got to find the derivative then. The derivative, now this we could solve for y, but it would be two different square roots, and it's just much easier just to take the derivative right here. The derivative of x squared is 2x. The derivative of y squared is 2y, but tack on a y prime. And then the derivative of 100 is 0. You have to be very careful because a lot of people will take that constant and bring it down, and then you've got the wrong answer. So y prime equals, I'm going to subtract 2x over and divide by 2y, which means negative x over y. So the question is, find the slope when x equals 8. Well, the derivative is involving both x and y. So I know what x is, but then I have to solve for y. X squared plus y squared equals 100. So subtract 64 and I'm left with 36, so y equals 6. Both positive and negative 6, right? When x equals 8, y equals both the positive and the negative 6. So I've actually got two different slopes. When x equals 8, y prime equals negative 8 divided by 6, which is negative 4/3. And y prime equals negative 8 divided by negative 6, which is positive 4/3. So you've got this slope and you've got that slope. Okay? All right. Let's find the derivative. 4x minus 5x squared y equals cosine y. So the derivative of 4x is 4. And also, guys, when I'm working these, if you want to just pause it and test it yourself and then play the video, that would be probably a good idea, just to make sure that you can do it, okay? So the derivative of 4x is 4 minus, I said minus, I'm going to go ahead and consider, like, this is going to be product rule. I'm going to let negative 5x squared be f and this be g. So first, so negative 5x squared times the derivative of the second, the derivative of y, I'm going to go ahead and use dy dx here instead of y prime. So first times the derivative of the second plus the derivative of the first, which is negative 10x, so I could have said minus, times the second y, equals, and the derivative of cosine of y is negative sine of y times the derivative of the interior, dy dx. Anytime you take the derivative of y, you got to tack on either dy dx or y prime. All right, I need to solve for dy dx, which means I need to get all the dy dx's on the same side. It seems easiest just to move this one over here because there's only one dy dx term over here. So I've got 4 minus 10xy equals 5x squared dy dx minus sine y dy dx. So 4 minus 10xy, I'm going to factor out a dy dx, and I'm left with 5x squared minus sine y. And then I'm going to divide, so dy dx equals 4 minus 10xy divided by 5x squared minus sine y. And there's my derivative. Okay. I think that's enough to get you started on this, so I think I'm going to continue the notes together when we're together, and I'm going to go ahead and give you the homework so you can get started on it, and then we'll finish the rest together in class. Okay? So I would take a picture of that or write it down, and you can work on that, or you can just wait until we finish the notes together. All right.